Welcome to Buffalo, New York and the GM Tonawanda engine plant, where over 71 million engines have been built, including the new Gen 5 V8s we've come to see. The supercharged LT4 is the star of the show, now the most powerful production engine in GM's history, making 650 horsepower in the new Corvette Z06. We are here at the General Motors Tonawanda engine plant where they build their V6 and V8 engines and some four cylinders. This is Joe Calkins, who is the
Quality Engineering Manager for the
Quality Engineering Manager for the four-cylinder engines. Joe's going to give us a tour. Right now we're in the V6 and V8 portion of the plant. That's correct. And as you can see, they've won some awards here, including 2014 and 15 Ward's 10 Best Engines win for the LT4 V8, which starts as a rough machine block that gets its first features added by these CNC machines fed by overhead robots. Part of the $400 million retooling the plant received so it could build the Gen 5 small blocks includes the use of data bolts like this one, which has an RFID chip built into the head. This allows all 29 machining steps performed to the block to be tracked and traced. Plus, there's robotic quality control testing measuring down to the micron to further ensure everything is within spec. If the block receives a good smiley report, then it's on to the next process, where its cylinder bores receive a multi-step honing to produce the desired shape and surface texture for optimum piston ring sealing. The crank mains are also treated to a similar honing, and then it's time for the robots to work their magic again, this time using cameras as well as thread checkers and micron gauges to quality check the block. And as part of GM's intensive quality control testing, the blocks are also pressurized with air to ensure that there are no leaks in the water or oil passages. If the block passes all these tests, well then it's loaded onto a sled and sent off to the main assembly line. So from what we've been told, this is where the magic happens. You guys want to maybe quickly run us through what process happens here?
Yeah, so those blocks that we finished machining, this is where we load it on the assembly line. This is where the engine starts its life. We assign it a serial number, and from there we build the engine up all the way through the end where we send it out to Bowling Green to be put in the Corvette.
This is where the block gets treated to pistons, rods, and crankshaft, and it's also where you really get to see the highly skilled workforce at Tonawanda strut their stuff. There's still some automation here, particularly when it comes to heavy lifting and torquing bolts to spec, but key components like the pistons and rods, bearings, and crankshaft are all installed by hand. The rods get torqued to the crankshaft after the piston and rod combo are popped into place. This blue tool, invented by one of the line workers, prevents the rod from being pushed in too far and potentially bending an oil squirter. Next, we toured the crankshaft machining department, the scale of which completely blew our minds. The crankshaft starts out as a raw casting and then undergoes a series of highly advanced machining and micro-polishing processes to produce the finished product you see here. The journals are cut in a process called turn-to-turn broaching, where both the crankshaft and the tool wheel are spinning. That's when the micro-polishing begins, starting with an 80 micron micro-finishing tape and moving on to an even finer polishing tape after that. Electronic measuring sensors are used to ensure the finish is perfect to within 8 microns, or the width of a human red blood cell. Over in the cylinder head department, things are just as advanced, with robots doing all of the assembly work and both human and electronic quality control checks, making sure everything is within spec. Pressing in the valve seats is a particularly important step in the process, since a leaky or dropped seat means big problems down the line. So important, in fact, that this next step involves the valve seats being wrapped or hammered into place, a precautionary step taken to ensure they're fully seated before the valve train is installed. Watching this two-handed robot assemble the entire valve train was definitely one of the coolest parts of the plant tour. Prior to the Gen 5 retooling, the plant used to have a separate robot for each of the steps you're seeing here. But now this single station is able to install the valves, springs, retainers, and seals, and all in record time. The blue and orange trays you see the robots pulling parts from are loaded by hand and then checked by a camera to ensure that all the parts are there and in position before they are sent to the machine for final assembly. Back on the main assembly line, these freshly built LT4 heads are mated to the LT4 6.2 liter blocks once the head gaskets are dropped in place. Then the head bolt torquing machine is lowered into place, with all the head bolts being torqued to spec simultaneously, ensuring a perfect seal around the entire mating surface. Because direct injection uses very high fuel pressure, the fuel system undergoes a defect detection test using pressurized helium and mass spectrometer technology capable of spotting a leak down to the micron. The long block is then leak tested and put through a cold test where it spun up to 2,000 RPM while checking over 12,000 test points, including the variable displacement oil pump, variable valve timing, and active fuel management. After that, the LT4 is equipped with its crowning jewel, a 1.7 liter supercharger that revs to just over 20,000 RPM and makes a peak of 9.4 pounds of boost. The addition of a supercharger only increases the overall height of the engine by 1 inch compared to the LT1, an engineering feat accomplished both by the compactness of the blower and manifold, but also by locating them deeper in the engine's V. After that, the stainless cast exhaust manifolds are robotically torqued in place, and then the LT4 engine cover is bolted down and protected for shipping. From there, a series of quality control checks are conducted to make sure all the sensors and even the oil filter are correctly installed before it's loaded onto a truck bound for Bowling Green, Kentucky, where it'll be dropped into a 2015 Z06 and sold to someone with a very serious need for speed. But before we wrapped up our tour, we were lucky enough to have a chat with third generation plant worker and union chairman Bob Coleman, as well as plant manager Steve Finch, both of whom offered some great insights about Tonawanda, its staff, and its recent retooling.
So we are here with shop chairman Bob Coleman, who's going to tell us a little bit about the role of the folks here.
The role. I'll tell you what, this is probably the top engine facility. I call it the Ponderosa. It's one of the largest. The membership here, I call it a team because it is a team. It's management and union. We work together here. We try to get everything done just so we can get the best product out in the facilities. You know, the cars, Malibu, look at all your trucks on the road. I'm proud of the membership here. The people do a great job.
So I'm here with Steve Finch, the plant manager at Tonawanda. Steve, can you tell us a little bit about the plant?
The plant, as you see it here, was built in 1938. That's when we started production here. The plant's gone through, in that many years, a lot of transition, right?
Yeah.
We even built airplane engines at this facility during World War II days. But, you know, of recent history, we've been building a lot of different models here, including the small block V8, the big block V8, as well as high feature V6 and high value V6 that was built here at this location. A couple 4-cylinder engines, so a lot of engine building history here. Many millions of engines have gone through this facility.
Incredible. And we're obviously intrigued by the LT4, the big boy of the GM lineup now.
Absolutely.
How did that come to pass as far as this plant being chosen to manufacture that engine?
That's a really difficult question to answer. decision that GM makes of where to actually put products and what plant and facility is a multifaceted decision-making process. They look at the quality, ability of the production facility. They look at the financial history in terms of are we able to meet budget and perform well. They look at the ability for the transportation part of the equation to be solved. How close are we in proximity to where the customers are and the transportation modes? And so there's a lot of different factors that go into it. I really like to believe that when they look at the history of Tonawanda and this engine, we've had a really rich history of building great products here. The small block, this is really the home of that engine. So I think there was a little bit of sentiment as well in placing the new version of that engine back here at its home location.
Incredible. That's really exciting. Well, we really appreciate you having us here. It's been a mind-blowing experience to see the level of technology here, the amount of effort that goes into testing and retesting is just phenomenal. So thank you very much. We really appreciate it.
Just remember, it's not just the technology, but it's the people that really make the difference, right?
So
I mean, it's we've got an amazing team here. They come and do a fantastic job and keep the machines on track.